Nobody thought data centers would become one of the biggest energy stories in America. For years, they were just part of the background. Quiet buildings full of servers, tucked away in industrial zones, powering websites, apps, and cloud storage without most people ever thinking about them. But AI changed that. Now those buildings are no longer just storing information or supporting the internet. They're becoming giant electricity machines, pulling so much power from the grid that some of the biggest companies in the world are no longer asking how to get cheaper electricity. They're asking something much more serious: how to guarantee enough electricity at all. And that is why this story matters, because the AI boom is starting to run into something the tech world cannot code its way out of: power. At first glance, that sounds strange. AI feels digital. Electricity feels old. One sounds futuristic, the other sounds like wires, transformers, and utility companies. But the truth is much simpler. AI only works because huge amounts of physical infrastructure are sitting behind it. Every chatbot response, every image generator, every code assistant, every enterprise AI tool depends on massive data centers running around the clock. Those data centers need land, cooling systems, backup power, networking equipment, and above all, enormous amounts of electricity. And as AI models get bigger and more widely used, that electricity demand starts climbing very fast. That is where the real problem begins. The AI industry moves at software speed. It's used to scaling quickly, launching new tools quickly, and expanding into new markets quickly. But the power system does not move like that. You cannot build new generation capacity overnight. You cannot expand transmission lines in a few weeks. You cannot solve grid bottlenecks with a software patch. Power plants take years. Grid upgrades take years. Permits take years. Local approvals take years. So now you have one of the fastest moving industries in the world running directly into one of the slowest moving systems in the economy. And that mismatch is starting to define the next phase of the AI boom. This is why some of the biggest companies are starting to think differently about energy. Instead of simply plugging into the grid and assuming the electricity will be there, they're looking for more direct control. They want dedicated supply. They want guaranteed access. They want arrangements that reduce the risk of power shortages, delays, or price shocks. In plain English, the companies building the future of AI are starting to behave like they don't fully trust the existing power system to keep up with them. And that's a big signal, because once a tech company starts planning around electricity like it's a scarce strategic resource, this stops being a normal growth story. And the reason it stops being normal is because electricity is not just another business cost, it's the foundation under everything else. If you cannot secure enough power, you cannot expand your data center. If you cannot expand your data center, you cannot train larger models fast enough. If you cannot train larger models or serve more users, the products on top of that system start hitting limits. Suddenly, the conversation is no longer about who has the smartest AI model. It becomes about who can actually power it at scale. This also changes the relationship between data centers and the grid itself. For a long time, the assumption was simple. If a company needed more power and was willing to pay for it, eventually the grid would make it happen. But AI demand is getting so large and rising so quickly that grid operators are starting to push back. They're looking at these enormous new loads and saying, in effect, if you want this much electricity, you may need to be more flexible. You may need to reduce demand during moments of stress. You may need to shift usage. You may even need to bring some of your own power. That's a major shift. It means data centers are no longer being treated like ordinary customers. They're being treated like giant industrial power users whose behavior can affect the stability of the whole system. And that sounds reasonable until you remember what these facilities are doing. AI data centers are not quiet archives that can casually switch off for a while. Many of them are supporting tools people use constantly, businesses depend on daily, in systems that are expected to stay available all the time. In that world, flexibility sounds good in theory, but in practice, it can become expensive. If your entire business depends on non-stop uptime, being told to occasionally pull back power use is not a small inconvenience. It's a serious operational problem. So now there's a growing tension. The grid wants flexibility. The AI business model wants reliability, and both sides have a point. This is why the crisis is deeper than people think. It's not just about power demand going up, it's about three different systems colliding at once. First, there's the AI economy, which rewards speed, scale, and non-stop expansion. Second, there's the power grid, which rewards caution, reliability, and long-term planning. Third, there's the financial world, which is already valuing AI companies as if this growth will continue smoothly and almost endlessly. Put those three systems together, and electricity stops being a background issue. It becomes a choke point. It becomes the thing that decides how fast this whole story can continue.
That is why companies are now exploring more aggressive solutions. Some want dedicated generation near data centers. Some are looking at gas-powered facilities. Some are interested in reviving old power assets. Some want backup systems that reduce dependence on the public grid. And all of these ideas point to the same conclusion. Big tech is increasingly treating electricity the way it treats chips or cloud infrastructure, as a critical strategic input that needs to be secured before someone else gets there first. But once that starts happening, another problem appears: politics. Because when giant data centers start consuming extraordinary amounts of electricity, local communities notice, utilities notice, regulators notice, and regular consumers start asking a very simple question. If all this new demand is hitting the system, who pays for the upgrades? Who pays for new transmission? Who pays for reliability measures? Who pays when the grid gets strained? That is where the story stops being about private innovation and starts becoming a public issue, because the power system is shared, and once one group starts putting massive pressure on that shared system, the costs and risks do not stay private for long. There's also a deeper lesson here about the way technology is often discussed. AI is marketed like something weightless, almost magical. It lives in the cloud, it responds instantly, it feels intangible. But none of that is actually true. AI is physical. It lives inside buildings. It runs on chips. It generates heat. It needs cooling. It needs land. And, most importantly, it needs electricity in quantities that are starting to change the energy conversation itself. The cloud, in reality, is a warehouse full of machines drawing power every second, and the more advanced AI becomes, the heavier that physical footprint gets. That is why this issue is not going away. If anything, it's becoming more important, because the more useful AI becomes, the more people use it. The more people use it, the more compute is needed. The more compute is needed, the more data centers expand. And the more data centers expand, the more pressure they put on the grid. So this is not a side story. It's not some random utility issue happening on the edge of the tech world. It's one of the main constraints on the entire AI growth model. And that is what makes this crisis so important. The next phase of AI may not be decided only by who builds the best models, launches the best products, or attracts the most users. It may also be decided by something much less glamorous. Who can secure enough electricity? Who can build where power is available? Who can handle curtailment? Who can absorb energy costs? Who can keep scaling when the grid is under pressure? That is a very different kind of competition. It's not just digital, it's physical, and it may end up mattering more than people expect. In the end, the AI data center power crisis is getting worse for one simple reason. Demand is rising much faster than the system built to support it, and once that happens, the winners are no longer just the companies with the smartest software. They're the ones that can keep the lights on.